All right, party people, it's day 15 of Advent of Code. Excited to get started. We're going to be 60% of the way through this journey shortly, and what a journey it's been. I've got the code set up. I think most of the things are ready to go. I even have the stopwatch queued up, so let's switch over to the desktop here. Got day 15. Our little diagram is really coming together with our little island here, it looks like, of our journey. And yeah, let's start that stopwatch and get right into it. 15. We catch the airport shuttle, book a new flight to your vacation island. Due to the storm, flights have been canceled, but a route is available to get around the storm. While you wait for your flight, we check in with the elves back home. They're playing a memory game and are ever so excited to explain the rules. It's amazing how the way this puzzles, it's like setting up as like, oh, we have this storm and we're gonna route around it. It's like, oh no, we're playing a memory game with the elves. Like, okay. In this game, the players take turns saying numbers. They begin by taking turns reading from a list of starting numbers. Let me just confirm our sound situation. Okay, cool. Starting numbers. Then each turn consists of considering the most recently spoken number. If the first time the number, then each turn consists of considering the most recently spoken number. If that's the first time, the current player says 0. Wait, which number? Otherwise, the number had been spoken before the current player announces how many turns apart the number is from when it was previously spoken. Okay, so every number gets queued up to 0 in a list, and then, or it doesn't exist, you can get with a 0 on a dictionary, and then when it gets said, we say what turn we're on, and we store that, and then we update it each time. After the starting numbers, each turn results in that player speaking out loud either 0 if the last number is new, or an age. Why an age? If the last number is a repeat. Starting numbers are 0, 3, and 6. Now consider the last number spoken, 6. Since that was the first time the number has been spoken, the fourth number spoken is 0. But since 0 had been spoken before, the next number to speak is the difference between the turn number it was last spoken and the turn number of the time it was most recently spoken before then, turn 1. So then someone says 3, and then they say 3, and it's like, oh, but 3 was spoken on turn 5 minus 6, so say 3 again. It's spoken in a row. The last two turns are 1 apart, and thus number spoken is 1. 1 is new, so the 8th number spoken is 0. Oh, that's kind of cool. The game ends when the elves get sick of playing, or when dinner is ready. What will be the 2020th number spoken? Cool. Nice. And here's my puzzle input. Shockingly short. Okay, in that case, since it's so short, let's do this example then. All right, over to PyCharm. We've got our puzzle input. In this case, I'm not going to do any sort of fancy parsing here. We're going to say each thing that gets spoken gets enumerated as a list, turned into a dictionary. So what happens if I do that? Cannot convert dictionary element, blah, 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 blah. Okay, that's fine. We'll just do it the old-fashioned way. So we need to store the turn on which it was last spoken. So input or init, init, and then we say for value in enumerate init. We're gonna do memory at value is I. So we're saving the last turn, the last time it was spoken, right? And so now for each time after that, for range I in range 4 to 2021, because we want to get to 2020, turn number 2020. So now we're on turn 4, so to speak. Oh, that is awkward though, because for I, okay, we'll say I plus 1. Because there's no 0th turn as far as I'm aware of. Right? 0, it had been spoken before the first number spoken on turn 1. So we are doing a 1-based system. So we have plus 1 here. First turn is 1, not 0. For a range of 4 to 2021, each time we go through, all we need to know is the previous number that was spoken. So prev equals init at -1. And then we say we have to determine what to say next, which is based on memory get previous comma 0. And so this is the turn that it was last spoken on. Turn last seen on turn number what? And so if it was last seen on, let's say here, right? The last seen, since that was the first time, instead of the next last number spoken 0, it had been seen before. The number between the difference between the turn it was last spoken 4, and the number of time it was most recently spoken before then. Oh, so we need 2 of them to be saved? Ouch. Yeah. Right? There are no repeats in our normal inputs? Yeah. So I think I need to save this as a list of every time it's been seen. I mean, really, I only need to see the, it's only one layer of look back, but at this point, we may as well just store the whole thing. So it's like last seen, and then what? We say if it was not seen. Let's just do it that way. If prev not in memory, then it's 0. We just get what did we say? It is considered number 6. If that was the first time it was spoken, then the 4th number is 0. So then we can just set memory at I equals 0. Now if it has been seen, else we take the list and we say it was last seen previous not in memory. Oh, it's not that it's not in memory, right? Now consider the last number spoken 6. We put a 0 there. And then on turn 5 we look at it and it's like 0, 0, 3, 6, 6, 0. And then on turn 5 we look at the previous number and we look it up and we get a list back that says 1 comma 4. Ooh, it should be 1. This should be 1. If previous is not in the memory, hold on here. Before we do this, if previous is not in memory, 6 is not in memory, we put a 0 as the next number that's spoken. So there needs to be a different track of the number that's spoken versus kind of the history of things that are in there. Because memory is not at the yeah. So it's like you look back and you're like, oh, 6 is not in memory. but 6 is in memory. It's not that it's not there. It's definitely there because we put it there. It's more that when we get it, right, like memory at prev will always work, and if it doesn't, I want that error. And so this will be list of occurrences. And I'm spelling occurrences wrong for no apparent reason. Will this fix it? Aha! Occupancies. No, occurrences. And if we've only seen it once, then the length of occurrences will equal 1. So if that's the case, then memory at 0 will be appending. Everything is like flipped around, so it's wrecking me here. So then it becomes that, like that. Else, right? Else, if it's bigger, then we say here, like we're like this, and we're, oh, and we need to set previous to I. And I think we can continue, but that's tentative. And then we loop around and we're like, okay, what's previous now? Previous is 0. And when we look at our map of values, we see that 0 was last seen prior to that, right? So we say occurrences at -1 and -2. So that's a -1 is a bigger number. Occurrences at -2 is a smaller number, should be the one that came before it. That number is itself the one that gets spoken, and thus is our new previous. Spoken. So previous equals spoken, but also memory at spoken append I. And it's possible that memory at spoken doesn't exist yet. So we say memory dot get spoken, return empty thing, memory at spoken equals that, and then we append it. Yeah. And we should do something similar up there. Yeah. So really the if statement we care about, so this should all go out 1. This should go away. This previous is I? Previous isn't I? Previous is 0. It's the value that's spoken. And instead of us doing this manually, if the length of occurrences is 0, then spoken is 0. Sorry, is 1. Right? It's saying that if it's the first time it's spoken, then it's nothing. Now whatever gets spoken is set to the next thing. Every turn we have to append something to our kind of list of what gets said. And so I'm going to clear this bit out. And I think I'm going to print memory each turn because it's crazy. Maybe also what was spoken. Also known as prev by this point in the loop. Let's try running it. It stops at some point. Oh, up to 2020, yes. So what do they want to know? The thing that was spoken on the 2020th number? Okay. 436. Oh crap, I got it. Okay, it worked. I just wanted to see. Oh wow, that's a lot of printing. Ooh. Okay, let's not print all of that and instead change our inputs to, what is it, 132? Input is 1? Wow, that's crazy. Let's try this one. 312. Alright, pretty happy with that. If this doesn't work, I will be sad because I literally won't have 0. Yeah, I was like, that can't be right. What? How is it that those are all right, but then this was wrong? It must be the presence of a 0 already in the input is throwing me off. Well, I hope not, but I guess that's possible. So let's just print memory when we start this whole thing. So the first turn, so we have 0, 1 is at the first one, 2 happened the third time, 3, 4, 5, 6. And after the first turn, we have here we go. We have introduced prev, which it claims to be 0. Oh, yeah, I guess that's fair. Because the next number, it'll look back and be like 13. Haven't seen that before. 0. And then it'll look back and it'll be like 0. Why is this 2 and 4? This should not be 4. Right? Append I. Oh, this number is hard-coded. Yes, that is the problem. Len of init plus 1. That is what's missing. Ooh, that was dirty. Giving us examples that are all in the all 3 numbers long. That's what I get for not generalizing. All right, how do we do there? 17 minutes. All right. So yeah, these puzzles are definitely, either I'm getting slower and more methodical, or maybe just slower. What? Determine the 3 gajillionth? How long does that take to run? And do I want to be here when it finishes? Because that's 330 million. Does this have cycles? Oh man. Let's see, 0, 3, and 1. Let's try it, I guess. Like this, that, I don't know. Like, this is gonna take a while potentially. If I divisible by, what did I say this is? 30 million. Print I. I always forget to write equal sign here. Like, I was actually thinking about it that time, and I was like, don't forget to do that. And then I forgot. So, I wonder what the limiting factor here will be. I mean, 30 million is, it's not tiny, but like, we'll get to it. We'll get to it. I hope. Was I just being impatient last time? Are these running any slower each time? No, they're just ticking by, right? 6, 27, 28, 29, 30. Huh. Getting to 30 is a little extra work. So 175, 594. Okay. So I'll just run it, I guess. I don't know. Like, I suppose I could prune our map some to like speed it up. And I assume there's a pattern to the way the numbers fall, but like at this rate of computation, it's like not worth it for me to calculate it out, you know? But like these must be some pretty big numbers that are going to come out. And there's a number. Did we just brute force it? In 20 minutes. All right. I'll take it, I guess. I kind of feel bad. But I don't. You know, like... All right, let's try printing out prev each time. And just doing 2020. $30, 1, 2, 3, 4, 5, 6. And yeah, I mean that's just a strict increment. Okay, let me try 20 rounds then instead of 2,000 rounds, and we'll do our smaller input again. And I mean, I don't really see a pattern at a glance. Could try like 200 rounds. Like this is clearly just like a look back system. I don't know that there's any patterns here, folks. But I'll definitely be looking into this a little bit because I am kind of curious. But I am also just like glad to have something that's not super hard, like tedious, you know, like we could just basically follow the instructions, do what it says. Like, yeah, we had to think through these indices a bit. That was a bit of a pain. But yeah, we got to work, and I'm reasonably happy with that. You know, I also, yeah, just changed that by accident. Whoops. Okay, commit -am. Move the print. All right, so that's 15 in the books. 60% of the way there, and excited for what's to come when we get to day 20. You know, statistically, the folks who get to, historically, let's say, those who get to the kind of 20th-ish day tend to get through to the end. You know, you look at 2019 stats, and here they are. There's this huge exponential drop-off at the beginning, and then as the days go on, you know, we're finishing up. Day 15 here. These are last year's numbers. You know, things are evening out, and so I am hopeful that we'll be able to make it to the end, and I look forward to the pot of gold that's there, I guess. So until then, I'll see you tomorrow for day 16.